As the battery gets closer to full, it's harder and harder to find a spot. They have to bounce around more.
CEO Elon Musk unveiled a new generation of electric batteries.
Less than 2 weeks after leaving DOGE,
Elon Musk has one more government job to cut, his own. The billionaire who became President Trump's chief cost cutter is leaving his temporary government position.
Elon Musk surprised the world by confirming Tesla's latest patents for a next-generation system that runs on aluminium-ion chemistry and recharges in just 15 minutes. The news hit the industry like a shockwave, raising exciting speculations about what else Tesla might have in store for 2026. But how true is this claim? And are there clues of its development in Tesla's history? Join us as we trace the hidden roadmap behind Tesla's next-generation super battery, Tesla's need for better energy storage. As impressive as it sounds, the long road to Tesla's latest breakthrough was far from easy, fraught with many obstacles going back as far as early 2004. After a stakeholding investment of $6.5 million, Elon Musk joined Tesla as a major shareholder.
CEO Elon Musk has added another investment to his portfolio, becoming the largest shareholder.
As we shall see, this was a very interesting time in the auto industry's long history. GM's Oldsmobile brand, which had operated for over a century, was now shutting down. BMW had just launched its first 1 Series luxury series.
BMW presents the next 1 Series with a fresh design and new engines.
And the Mercedes-Benz CLS class had made its debut. Enter the new company on the block, Tesla Motors, now led by the future tech billionaire. Tesla at the time was nothing more than a tech startup with the right ideas but lacking the resources to pull through. Elon's goal at the time was simple: create a fast and stylish electric sports car with the best features. On the surface, this sounded like a very achievable goal for Tesla. The problem was that the car would somehow run on the same type of batteries found in laptops and cell phones. In other words, it was going to be an EV, running entirely on lithium-ion batteries as the power source, and launched as part of an industry that was barely struggling to find its footing back then. Many liked the idea of EVs only because they didn't pollute the environment as easily as regular cars did. The problem was that the batteries didn't last long and were very prone to overheating over prolonged use. But Elon Musk had one big idea up his sleeve. You see, the reason why lithium-ion batteries were so inconvenient for cars was that even though they were reliable for electric gadgets,
the future is electric. Everything from cars to consumer electronics to renewable energy storage is dependent on our ability to build more and better batteries.
On a larger scale, they were simply not designed for vehicles. Just the early Tesla team believed they had found a way out of this. They postulated that by grouping thousands of small lithium-ion batteries together, they would be able to produce the energy required to run the first high-performance EV on the market. Though this plan worked well on paper, many Tesla employees would later make it clear that Elon never saw it as the main goal. Lithium-ion batteries were nothing more than a temporary solution required to give the company a head start in the very competitive EV industry. Elon believed the future needed something far better than anything the world had ever seen before: a power source that would make fast energy accessible more than ever. The power source Elon had in mind sounded a lot like science fiction back then. We are talking about a battery that fully charges in minutes, lasts for decades after thousands of cycles, and is easily built by multiple factories without needing rare and toxic chemicals for manufacturing and maintenance. Many thought this dream was an overblown fantasy until he started public discussions hinting at various alternatives that sounded strange to everyone. Among the alternatives he mentioned in 2006 were ultracapacitors and aluminium-ion cells.
The area that I was studying was advanced capacitors. Right? So essentially capacitors that have an energy density exceeding that of batteries.
These options were discussed in full detail behind closed doors, while the public narrative was that Tesla was trying to prove lithium-ion batteries could work in high-performance EVs. Among the two alternatives mostly discussed in terms of cost and supply, it seemed aluminium-ion was the way to go. For one, aluminium was the most metal available for mining. Better yet, it was a lot cheaper than lithium. The idea looked promising, especially considering how some labs had already created aluminium-ion prototypes that could charge in less than half an hour. The problem was that none could get past the problem of overheating and other major hazards from unstable electrodes. Not wanting that to hold him back, he first reached out to Stanford and Berkeley in 2007. He wanted to study the feasibility of using an aluminium-ion battery to power high-performance EVs with a fast charging speed that doesn't affect its lifespan. No public announcements were made, but it was later confirmed that Elon funded a few early studies in this concept through his private investment channels. With the future taken care of by researchers, Elon could now focus on the present efforts of his company. The result of those efforts was the Tesla Roadster. It launched in 2008.
Elon Musk pulls off an engineering feat. He sent his own kind of rocket man on board a Tesla Roadster
To the surprise and cheer of reviewers across the world. The most impressive aspect of the car was the battery. Reviews say that it used a lithium-ion pack that had over 6,800 battery cells inside. Add all of that together, and you have a high-performance vehicle able to reach 62 miles per hour in 4 seconds. This was a huge feat for the time, and many thought it was the perfect car for people willing to use a high-performance car without leaving a carbon footprint. Elon advertised the car as proof that EVs could be cool and classy, with the best specs on the market, and it worked. But while the world was amazed by his company's latest product, Elon Musk was far from satisfied. Charging took over an hour to complete, and the batteries were prone to overheating and degradation. But that was just the beginning, as things were about to get worse. The limitations of lithium-ion batteries. The Roadster's battery just didn't have the right features for the battery. Special improvements needed to be made at least until the research funded by Elon was able to put out something close enough to what he had in mind. But times were changing fast. The global financial crisis of 2008 had just hit.
This was the time a decade ago when the financial crisis erupted, a crash that most experts did not foresee.
Tesla was running out of money. Research on his upcoming battery had to be put on hold just so Tesla would not fold under debts. But even then, he got regular updates each quarter on the latest findings. Surviving the rest of 2008 was no small feat. Tesla had now lived through a crisis and launched its first car. On the surface, it seemed Elon's company was having the time of its life, as the CEO openly talked during interviews about expanding Tesla's lineup and building a large charging network that would provide charging at cheaper rates and higher speeds. Elon already had his vision set in stone. Tesla would no longer just build cars alone. Rather, it would function as an energy company, and the main focus would be on solving battery charging time with a new power chemistry. While other automakers saw the battery as just another component, Elon Musk made that the endgame. Tesla's long-term goal was now to create a battery that would make charging EVs as fast as filling a gas tank in ways lithium-ion power sources couldn't, and that goal would guide the company's future for years. But for now, Tesla had a short-term goal to keep its customers happy, and that was the Model S. Unlike the Tesla Roadster, which was built in limited amounts to make a statement in the industry, the Model S was the first mass-produced EV. It was a full-size sedan that could reach 250 miles on a single charge and accelerate faster than most cars running on gas. Many critics and customers loved the vehicle, and it won awards for safety, performance, and innovation. It was the first time an EV was taken seriously enough as a real alternative to gasoline. But yet again, the Model S had significant problems with its battery. Charging took a long time to complete, and even though it could run on a standard charger, that took up to 8 hours. Tesla, by 2014, had reached the goal Elon had in mind back in 2008 with their supercharger stations. These places could give a charge between 30 to 90 minutes.
One of the biggest perks of owning a $60,000 plus Tesla is that you get free access to their supercharger stations for life.
Actual charging speed depended on battery size, and the amount of time it took was such a bother that it seemed Elon was more vocal about the issue than even the customers who were expecting the setback from the get-go. He pointed out that even though there were improvements in energy density for their latest battery pack, the feasibility was reaching its limits. There was only so much a company could do to improve the same kind of product. Something new was needed. Tesla already had the tools to make their existing batteries last longer and charge faster. There were also better cooling systems and battery management software designed to get the best out of the vehicle to extend range and reduce degradation by a long shot. But even with all this put in place, the reality remained that high-speed charging produced heat at levels that grossly damaged lithium-ion batteries. Major improvements like this were only going to shorten battery life and increase range anxiety among users. Still, Elon doubled down on research in next-generation battery chemistry by expanding Tesla's battery R&D division. Elon Musk had now hired specialists in electrochemistry and solid-state science engineering. This time, however, both teams weren't just focused on aluminium-ion, but other alternatives like lithium metal and hybrid supercapacitor systems. Lithium metal batteries were considered because they gave a higher energy density than lithium-ion and used pure lithium anodes that made batteries last for much longer under stressful conditions, like the fast charging Elon had in mind. But this would be later discarded due to rising concerns from hazards like dendrite formation that led to short circuits and a much shorter lifespan than promised. So, what about hybrid supercapacitor systems? Well, they had much higher endurance for heat and other hazards that come with fast charging, along with higher power output and improved safety, much better than lithium-ion and lithium metal. However, the biggest downside that caused this alternative to get replaced was that hybrid supercapacitor systems had much less energy capacity than lithium-ion batteries. It turned out that the slightest mistakes in the buildup and manufacturing could lead to catastrophic accidents on the road for users. By late 2012, there seemed to be hope on the horizon, with an internal presentation hinting at a power source for upcoming Tesla models that could charge to completion in 15 minutes. It was spoken about as a future goal and not something set in stone, hinting at the fact that all their recent efforts weren't working.
Elon Musk is denouncing the war on Tesla.
By December of that year, Tesla had started working with various labs from different institutions to test the earnest versions of dry-coated electrodes and aluminium foils with the highest conductivities. To cut costs, these experiments were basic and straightforward. The results were especially promising, as they showed that aluminium-ion cells could offer fast charging when paired with stable electrolytes. While this discovery wasn't a lot in terms of improvement, it was enough to keep operations going with high optimism for Tesla's next Herculean effort. That enormous task was crucial in building the battery he had in mind, the world's largest battery factory. Named the Gigafactory 1, it was located in Nevada and was designed to produce more lithium-ion cells and all other factories combined, a very ambitious project designed to limit how much Tesla relied on other companies for building its batteries. Though the general idea was for the Gigafactory to produce more lithium-ion batteries in a shorter time, the layout used in the manufacturing process was designed to be flexible enough for other projects, including Tesla's upcoming Model 3. The initial plan was for this new model to launch with the aluminium-ion battery they had been working on for almost a decade at this point. But continuous delays and hurdles had kept that dream from becoming a reality. The second reason behind this inherent flexibility was for the workers to test how new materials like aluminium could be added into high-speed manufacturing for future endeavors. By 2016, Gigafactory 1 was now producing thousands of lithium-ion packs with each stock. Behind the scenes, Elon Musk had established a separate path for lithium to be replaced. And when that day comes, Tesla would have all it takes to make it happen. What happened next was nothing short of breathtaking. Tesla's roadmap to the super battery. By late 2018, it had been a whole decade since the Roadster launched, and Tesla still hadn't released the dream battery Elon had in mind. Wanting to speed up the process, Tesla bought Maxwell Technologies.
Tesla coming out just moments ago, the automaker announcing the acquisition of energy solutions provider Maxwell Technologies,
a company that specialized in dry electrode technologies. The public narrative was that they would help Tesla improve their lithium-ion batteries. But as we know, the real benefits went much deeper. Dry electrodes improved faster charging with better thermal stability. Both benefits were very important for future aluminium-ion designs compared to traditional wet coating methods that limited voltage and increased the risk of fire outbreaks. Maxwell's methods of making batteries solved both problems, and Elon Musk instructed Tesla's battery R&D division to start using Maxwell's methods for all their testing procedures with power sources that utilized aluminium-based chemistries. We know this because Tesla's internal documents later showed early success with dry-coated aluminium anodes dating back to this point in the company's history. They also found success with experimental electrolytes that supported fast ion movement during charging. These tests brought the experimental battery packs to a charging time of about 25 minutes, close to what Elon had in mind, but not yet on the mark. These hidden exploits became public in September of 2020 when Tesla hosted Battery Day and revealed their new 4680 cell.
You actually have a shorter path length in a large tabless cell than you have in the smaller cell with tabs.
Interestingly enough, though it was still lithium-ion, it showed all the improvements they had made with their aluminium-ion units. All the changes made pointed to this, like the tableless design, improved thermal control, and the simplified buildup. Elon Musk described the 4680 as a platform for future materials and not as a final product. At the end of the event, Elon hinted at other battery chemistries in development, without mentioning aluminium-ion directly. Later on, it was confirmed that Tesla's engineers were already designing the 4680 platform to be backwards compatible with dry aluminium electrodes for faster charging capabilities. Now it wasn't about improving lithium anymore, but preparing for the right time to have it replaced. The new 4680 battery system will drop with aluminium-ion technologies very soon. From 2021, most of the work on the aluminium-ion battery happened at Tesla's Skunk Works R&D near Palo Alto, with many engineers working with graphene-infused aluminium anodes and solid-state compatible electrolytes. This was done to silence the tokens of low-voltage output and fast cycle degradation. Progress was slow but undeniable at this point, and by the summer of 2023, many internal tests showed aluminium-ion pouch cells with over 1,000 charge cycles and full recharges in 12 minutes at room temperature. These prototype battery packs were tested in special Model 3 EVs that had been modified to function as test mules. These cars were running at full speed in various extreme climates, such as the Arizona deserts and Canadian winters, to get her more information on the new battery's limits. The results were promising, with excellent thermal control and fast charging to 80% in under 10 minutes with Tesla's V4. Early 2025 came, and Tesla began to file its patents, with Elon Musk making the reveal not long after and confirming its official launch in the summer of 2026. After Elon Musk talked about Tesla's new aluminium battery, other car companies started paying close attention. In Germany, big names like BMW and Volkswagen began thinking about changing their factories in the future to build batteries like Tesla's, even though they're not yet being sold. In the US, small battery companies that were already working on aluminium ideas became more important. Investors started putting more money into them because they believed Tesla's plan showed that these batteries might be the future. While the battery's energy density is not a generational leap beyond that of the current 4680 lithium-ion cells, What makes it interesting is that the prototype kept over 90% of its original capacity after 3,000 full charge cycles from point zero. Each of these cycles had little to no thermal increase during each cycle and did not rely on nickel or cobalt to meet high performance. While Elon was careful not to give strong promises beyond the vague release window of summer 2026, he expressed hope that the new battery would enter limited production by the fall of this year before getting fully integrated into newer units for their current lineup of cars. The next generation of EVs built from the ground up would be showcased for release at the same window as the super battery pack. While this statement was given without assurance, what he did confirm was that the dry electrode lines installed after the Maxwell acquisition were already compatible with aluminium-ion cell manufacturing. To keep up with future demand, Elon plans for Tesla to start limited production of electric trucks and Powerwall Ultra systems, and by early 2026, the upgraded Model Y and Model 3, adjusted for the aluminium-ion packs, would roll out for the newly revamped Supercharger 5 stations. Just like that, what started as a secret internal effort quickly became a global shifting point, and if this succeeds, Tesla would not only achieve a technological breakthrough, but would rewrite the rules of the automotive and energy industries. So, what do you think? Is Tesla's next-generation super battery going to change everything as Elon believes, or would it be another disappointment like the one used in the Cybertruck? Let us know in the comments down below. If you enjoyed the video, please make sure you like, share, and subscribe. Also, click on the next video shown on your screen. You will enjoy it.